Here's all my work and all my answers. If you want to check a bunch of that stuff, letter A is a theorem problem. Couple theorems you can actually use on there. Let's just kind of review Rolle's theorem though. It says if you have a continuous function and differentiable function, and if you have two y-values that are the same, f of A equals f of B, then there's a spot where that derivative is equal to 0. So like on letter A, it's talking about this is the velocity for P, right? And then it's talking about is the derivative equal to 0. So right when I saw derivatives equal to 0, we're supposed to think of Rolle's theorem right there. Now, and so what I mentioned was, hey, it told us it was differentiable. And if something's differentiable, it's automatically continuous. So I put that velocity of particle P as continuous and differentiable. And I got the f of A equals f of B requirement satisfied because there I have two y values that are the same. F of 0.3 is 55, F of 2.8 is 55. And so those are the three stipulations from your blue packet that satisfies that Rolle's theorem right there. And so that's what you just got to mention all three things. It's continuous, differentiable, and F of A equals F of B. And I guess instead of writing it with the F's, I could have written it, I probably should have written it with the V's, which I just came up right here and said, okay, just to be clear, the V's, the y value is the same at both of those x values right there. And then, so if all three stipulations are true, Rolle's theorem guarantees at least one time where that derivative is equal to 0, and that derivative is the acceleration, which is equal to 0 right there. Another way that you could do this is use your mean value theorem. The Rolle's theorem is just a special case of the mean value theorem. The mean value theorem, you gotta have the derivative equal to a number, but if that number is equal to 0, it could be used as the Rolle's theorem. But the mean value theorem, it just has to be continuous and differentiable. And if the derivative is equal to this slope formula, then it's going to be okay there. So an alternate way you could do letter A is to just mention, hey, that thing is continuous and differentiable. And then you can do the slope formula with those endpoints, the 2.8 and the 3. And so it's just doing the slope with that point there and that point there. And you just subtract the y's on the top, x's on the bottom, and you get 0. And so that's your f of b minus f of a over b minus a. And so if that slope is equal to 0 and you have a continuous and differentiable function, the derivative must also be equal to that number right there by the mean value theorem. So two ways that you go about doing that. Letter B is the trapezoidal sum. All right, so we're going to draw on a few trapezoids. We're going to do the area formula for each trapezoid. Now remember, the area formula for a trapezoid is base 1 plus base 2 divided by 2. You average out the bases, and then you times that by the height. Now, normally I would draw pictures on here, and I would, do the area of each one of those trapezoids. Sometimes the pictures get a little tricky to me when I start having the negative numbers right there. So what I want to do real quick is just show you kind of how that pattern is. Like we have a pattern for a Riemann sum where you can do that without the picture. And I'm going to attempt to do that here with the trapezoidal sum. So if I draw a picture, this is just a completely different thing. I want to show you just with positive values what that pattern looks like there. So if you got the point 1, 5, and then you got the point 3, 12, and then you got the point 10, 25. All right, and I want to find the area of each one of those trapezoids. So you got the curve just going up, and then you just make your trapezoids like this, right? And then this is the top, this is the bottom. So this is your base 1, this is your base 2, and that height, that y value, is your base. It's like a trapezoid on its side. So this would be 5, this would be 12. So if I find the area of that, that would be 5 plus 12 divided by 2. And then you times it by the height, which is the distance between the 1 and the 3, which is equal to the 2 right there. Now, if you look at the table, what do? I did 5 plus 12 divided by 2, and then I times it by the distance between the 1 and 3, which was equal to 2. So I just know if I just do the next one without the picture, I know I'm going to go, so this first one I did 5 plus 12 divided by 2, and then I times it by the difference between that, which was 2. The next one I'll go 12 plus 25 divided by 2, and I'll times it by the distance between the 3 and the 10, which is equal to 7. So I just know that right away, and if we check that with the picture, I know this is 12, I know this is 25. So if I find the area of this trapezoid here, I can go 12 plus 25 divided by 2. And I'll times that by the height of that trapezoid, which is the difference between the 3 and the 10, which is equal to 7 right there. So we could do those without the picture, and that's what I'm going to do right here, just because sometimes when it goes negative, I'm not sure, it gets a little tricky in my mind sometimes, right? So what I'm going to do, if I'm going to do a trapezoidal sum, and I got the numbers all right here, but let me kind of share with you where I got that. And so you might just want to draw like a little picture like I just did, or draw like the first trapezoid, but that turns into a triangle. And then that way, when you get to the negative stuff, you can just do the pattern there. But I'm going to go 0 plus 55 divided by 2. times it by the distance between the 0 and the 0.3, which is 0.3. And I'm going to go plus 55 plus negative 29 divided by 2 times the distance between the 0.3 and the 1.7, which is 1.4. And then I'll go negative 29 plus 55 divided by 2 times by the difference between the 1.7 and 2.8, which is 1.1. And so that agrees with all of those numbers that I'm just doing right here. So just try that on your own, see if that pattern kind of makes sense there, and you can even use that on the other ones we did the trapezoidal sum on. And then this was a calculator problem, so you just plug all that stuff into the calculator, and you're gonna get this 40.75. Now, the question didn't ask for units on this one, so if as long as you got the 40.75, you were good. But I know whenever I integrate velocity, that gives me position, and so I know the meters per hour that the velocity started off is gonna turn into meters when I integrate that thing. All right, now letter C. We can get this, we just gotta be careful with the calculator work on this. It says a second particle Q also moves along the x-axis, all right, in between 0 and 4. So we have an equation this time instead of a chart. And then find the time interval which the velocity of this particle Q is at least 60 meters per hour. And then we're supposed to find the distance traveled by that particle in that time frame. All right, so one thing at a time. Let's find the time interval which velocity is at least 60. Now, at least 60 is greater than or equal to 60. So what you're going to do first is take that velocity Q, set that greater than or equal to 60. Now, this is a nonlinear inequality, and so you got to move the 60 over. Let's get everything on one side and set that greater than or equal to 0. Now, here's how you're going to, anytime there's a difficult equation to solve, you're not meant to solve that. The graphing calculator will help us out and solve this for us, okay? So what you're going to do is graph this whole thing into the calculator. And then, you know, if you need some help with this, rewatch that graphing calculator video I made for you. But graph this whole thing in the calculator. It has trig in there, so I put zoom 7. And then I went into the window button and I made it in between 0 and 4. So I put x min was 0, x max was 4, and then just this part of the graph pops up on the screen. And then, like I said, watch the graphing calculator video if you forgot how to calculate the zeros, but it will find those zeros for us. And so I used the graph calculator to calculate the zeros where that 1.866 and the 3.519 number. And then you want to know where that graph is greater than 0. Greater than 0 means it's positive, means it's above the x-axis there. So you're talking in between those two numbers. That's where that thing is there. So that's why, so I guess for this first part, which says find the time interval, that's what I need to have down first. I should probably squeeze it in there. That time interval is the 1.866 and the 3.519. All right, so that's like the first part of that answer, 1.866 to 3.519. And then, all right, sorry, I had some messy work and then I re-jotted it down. I forgot to jot that down, so I kind of confused myself for a minute. When it says greater than or equal to 0, we should kind of have those in brackets because you're thinking, where is that graph above the x-axis or equal to 0, which means it's crossing the x-axis there. So let it find the zeros for you. So that's the first part of that. So we got points for that. And then the second part of that, it wants to find the distance traveled by the particle. Now remember, the distance traveled is the integral of the absolute value of velocity. If it says displacement, that's the integral of velocity. Now, this whole graph that you're integrating right here is above the x-axis. And so if you forgot the absolute value bars there, you still would have gotten the right answer on this one, but it might have affected it would have affected our answers probably on the rest of that, on letter D or something like that, or another different problem. But distance traveled, you're supposed to know you're going to integrate the absolute value of that velocity in between that 1.866 and the 3.519. So you're going to math 9 that thing. So you math 9 it with those numbers, and then you're going to hit the absolute value bars and then enter that into your calculator, and it should give you that 106.109 meters right there. All right, now letter D is, it says we got this particle Q, that position, the initial position is equal to -90. And then it says use your result from letter B and this function from letter C to approximate the distance between the two particles at time t equals 2.8. And that's also why I stopped that trapezoidal rule at 2.8, because it told us to start at 2.8. That's why I didn't go on to the next one and go 55 plus 48 divided by 2 times it by that. So, all right, so anyways, particle Q, remember on the position problems, you always got to take into account the initial position. So if you want to figure out what distance, you know, how far or where's that particle q going? There's your initial distance right there, your initial position, right? And then when you integrate the velocity, it's going to get you position. So you go the integral, the negative 90 is your initial, and then when you integrate the velocity in between 0 and 2.8, math 9 that thing. Now you don't math 9 it with the 60, you just math 9 it with that, because that's your velocity of q. So when you integrate that, that's going to get you your position. You're going to take into account your initial position. It gives you this. And then here, your particle P, it tells us at t equals 0, that particle P is at the origin. So that initial position is 0. And then we already calculated the integral between 0 and 2.8 of that in part B, which is that 40.75 right there. And then the difference between those, you just subtract those numbers, you get the 5.188 number. And then remember, like if you would have made a mistake on this, and then use that wrong answer to get this, as long as you did that concept right, you just used the wrong number there, and then this answer right, you would have gotten full credit for this, but you would have gotten deducted for that stuff right there. So just try to be careful with that. I think this video probably could have been a little bit smoother, but we got through everything, and then just let me know if you have any questions, all right? Thank you. Reese's Peanut Butter Cups.